So the concept of coordinate system is very useful for analyzing any problem of electromagnetics. In this, first we will define orthogonal system. What is an orthogonal system? An orthogonal system is one in which the coordinates are mutually perpendicular. So if the coordinates are mutually perpendicular, that is perpendicular with respect to one another, then we can call a orthogonal system. So in our generally in the analysis of electromagnetics problems, we will follow orthogonal systems. The first coordinate system is Cartesian coordinate system. Cartesian coordinate system. Cartesian coordinate system. It is also called as a rectangular coordinate system. Already we have a small introduction to this. So in this Cartesian coordinate system, the three variables are, we will represent with x, y, z. X, y, z. The coordinate system is like this. This is x-axis, y and z. The three are mutually perpendicular, and we will follow here right-handed convention, right-hand coordinate system, like this: x to y, y to z, z to x. In this, the limit of x is minus infinity less than x less than infinity, minus infinity less than y less than infinity, minus infinity less than z less than infinity. This is the range of x, y, z axis. Generally, we know that a vector a bar in a Cartesian coordinate system, a vector a bar in a Cartesian coordinate system is written as a bar is equal to ax, x bar, that is scalar component in x direction multiplied with the unit vector along x direction, plus ay bar plus az bar. So like this we can represent a vector in Cartesian coordinate system. So this is a very well known system. The second coordinate system is cylindrical coordinate system. Cylindrical coordinate system. That is, suppose in electromagnetic, when you are solving any electromagnetic problem, this cylindrical coordinate system, cylindrical coordinate system is very convenient whenever we are solving problems, or whenever we are solving electromagnetic problems having cylindrical symmetry. In such cases, this cylindrical coordinate system is very useful. So suppose this is the cylindrical coordinate system like this: x, y, z. Suppose if any problem having cylindrical symmetry like this, circular cylindrical we are discussing here. So circular cylindrical distribution, in such cases it is very convenient to use cylindrical coordinate system. The variables here are rho, phi, z. Rho, phi z, whereas in Cartesian x, y, z, here rho phi z. So a cylindrical coordinate system looks like this. Any problem or any point in a cylindrical coordinate system is represented like this. Suppose this x, y, z I am taking as reference. So this is the cylindrical distribution. Suppose so this is the front view. This is the front view of a cylinder. Suppose if you want to represent a particular point, can represent like this. So this is a point. This is a point. This is rho. This is phi, and this is z. This is z. So this is the unit vector a phi. This is the unit vector a rho. This is the unit vector a z. So like this, I can represent a point on cylindrical surface. Here the important thing is what is rho, what is phi, and what is z. So I can define the variable rho as rho is the radius of the cylinder. Rho is the radius of the cylinder. Or we can define it as also as it is the radial distance from z-axis. That is the distance from z-axis to the point. That is called radial distance. So rho is the radius of the cylinder or radial distance from z-axis. Phi is called azimuthal angle. Phi is called azimuthal angle and is measured from x-axis. Because the surface, that is here we are assuming a cylindrical distribution, that's why this particular phi provides the angle at which the point locates with respect to x-axis. So phi is called azimuthal angle. So rho indicates radius of the cylinder, phi the angular point. And the next one is z. Z is same as rectangular coordinate system. Rectangular coordinate system. That is this is nothing but height. If you come to the range of values, the range of values is given by rho is the radius. So radius is starting from 0. Minimum value is 0. So 0 less than or equal to rho less than or equal to infinite. That is the radius. Now angle, since it is a cylindrical angle, we are assuming circular cylindrical. So circular means what is the total angle present? 360 degrees. So 0 less than or equal to phi less than or equal to 2 pi. That is the range of phi. Z, it is minus infinity less than z less than infinity. Less than infinity. So this is the range of the values. So which is very, very important to solve problems. Suppose if I want to represent a vector A bar in a cylindrical coordinate system, is represented as so A bar is equal to A rho bar plus A phi bar plus AZ bar. So like this I can represent a vector. Here another important thing is dot product and cross product notations. We know that A rho dot A rho, same quantity, same unit vectors 1, that is equal to A phi dot A phi, that is equal to AZ dot AZ. We know that A rho dot A phi, opposite one, or A phi dot AZ or AZ dot A rho is equal to 0. So this is similar as a rectangular coordinate system. Similarly, we know that A rho cross A phi, opposite ones, is equal to AZ. Here we are following right-handed convention, that's why it is AZ. Suppose A phi cross A rho minus AZ. Similarly, A phi cross AZ is equal to A rho. AZ cross A rho is equal to A phi. So these are some unit vector identities. Then what is the relationship? Suppose if you want to relate relationship between rectangular and cylindrical coordinate systems. How we can relate the two? Here, suppose if you draw the coordinate system, again, this is x, this is y, this is z. So this is I am calling it as rho. Suppose if I want to represent a particular point, this is a point. This is both are, this is rho, this is z, this is phi, at an angle phi. So this is point P, which is rho phi z. Similarly, this is also point P in terms of x comma y comma z. Then how I can relate? So you can easily relate like this. If you draw, this is nothing but y, this is nothing but x. So this is a z similar. So how we can relate? So y is nothing but rho sin phi. X is equal to, since it is rho, x is equal to rho cos phi. So you can write x is equal to rho cos phi. Y is equal to rho sin phi. Y is equal to rho sin phi. Z is equal to z. Suppose if you want to convert back, rho is equal to square root of x square plus y square. Y is equal to rho sin phi. We have to calculate phi. So phi is equal to x by y means y by x is tan phi. So phi is equal to tan inverse y by x. Phi is equal to tan inverse y by x. Z is equal to Z only. Z is equal to Z only. So with the help of these formulas, you can convert from cylindrical coordinate system to rectangular coordinate system or vice versa. Suppose a vector is given like this: ax, ay, az, a rho, a phi, az. This is in rectangular coordinate system. This is in rectangular coordinate system. This is in cylindrical coordinate system. So here a vector a bar is represented as a bar is equal to ax bar plus ay bar plus az bar. Similarly here also a vector is represented as a bar is equal to a rho bar plus a phi bar plus az bar. There is a conversion formulas. Here I am directly mentioning how to convert from, suppose a vector is given in rectangular coordinate system, then how to convert into cylindrical. A vector is given in cylindrical, how to convert into rectangular. So there are conversion formulas. Directly here I am mentioning those formulas. A rho, a phi, az is equal to cos phi sin phi 0 minus sin phi cos phi 0 0 0 1 ax ay az. So we can prove these things very easily. Of course here I am not going for proofs. Similarly ax ay az equal to cos phi minus sin phi 0 sin phi cos phi 0 0 0 1 a rho a phi az. So this is the conversion formula. So we can prove very easily. Here for example I am giving how to prove is, suppose a rho is equal to, how I can relate in terms of ax ay az, ax cos phi plus ay sin phi plus 0 into az is 0 only. So we have to prove this. We know that a is equal to ax cap plus ay cap plus az cap. A bar is equal to. Suppose x is equal to, I know x is equal to rho cos phi. Suppose unit vector ax is equal to a rho cos phi. Similarly y is equal to rho sin phi. Ay unit vector is a rho sin phi. So substitute these values here. So this is equal to ax unit vector ax is nothing but a rho cos phi plus ay unit vector ay is a rho sin phi plus az cap. So this is equal to suppose if you take a rho common, ax cos phi plus ay sin phi plus az, it is okay. Suppose the a rho component is nothing but what? A rho component is nothing but this one, ax cos phi plus ay sin phi. So like this we can prove very easily. So these are the conversion formulas. So my suggestion is, don't remember these formulas, because in gate point of view they may not ask these relations. Generally they will not ask. Suppose it is a theory point of view in our B level examinations, they may ask. But gate point of view, they will not ask the direct conversions. Even though if they ask conversions is not a problem, you can prove very easily if you remember the variables and relation between cylindrical coordinate system and rectangular coordinate system. So these are the conversion formulas. Next one is third coordinate system, spherical coordinate system. Spherical coordinate system. Spherical coordinate system. So the variables are r, theta, phi. R, theta, phi. Generally this spherical coordinate system is widely used when we are solving a electromagnetic problem having spherical symmetry. Having spherical symmetry like this type of symmetry, x, y, z, suppose some spherical distribution like this. Suppose if it has some spherical distribution, then this coordinate system is very useful or to solve this type of problems very easily. Here r, theta, phi we are having. The spherical surface front view, if you look, it looks like this. Suppose this is x, y, z. This is a coordinate system. That is, we can represent a point P on a spherical surface like this. This is a spherical surface, suppose. This is suppose point P on spherical surface. This is called distance r. This is phi. This is theta. This is a r. This is a phi, and this is a theta. This is the point P on a spherical surface. Here, how we can define these variables is r. R is defined as the distance from origin to point on the surface. Point on the surface. Theta is the angle. Theta is the angle between z-axis and position vector P. That is the angle between z-axis to radius vector. That is the position vector means nothing but here the basic point is 0. So the position vector r, nothing but this is the distance between z-axis and r. This is the angle between z-axis and r. Phi is same as cylindrical, and phi is measured from x-axis. Phi is measured from x-axis. So if you come to the range of values, 0 less than r less than infinite, 0 less than theta pi, 0 less than phi less than 2 pi. Here theta is only pi, that is 180 degrees. That is, suppose this is minus z axis, so the theta varies from full one half circle like this only. So the position vectors may be at any point. Similarly, in this direction also, it may be any point. That is, if you are measuring left hand side, you will calculate like this. You will calculate from like this in this direction. So the angle is only 180 degrees, not 2 pi, not 360 degree rotation. So this is the range of values of spherical coordinate system. Suppose if you want to represent a vector a bar in spherical coordinate system is represented as a bar is equal to ar bar plus a theta bar plus a phi bar. So similarly, the vector identities, unit vector identities are a bar dot ar bar equal to a theta equal to a phi dot a phi equal to 1. Similarly, ar cross a theta is equal to a phi. A theta cross a phi is equal to ar. A phi cross ar is equal to a theta. So this is we know very well. These are the vector unit vector identities. Then how we can relate? What is the relationship? Relationship with other coordinate systems. Other coordinate systems. So we can represent like this. If you draw, this is x, this is y, this is z. Suppose I want to represent a point P, which is a point P in all coordinate systems I want to represent. This is phi, this is z only, this is rho, this is rho. So this is rho means this is also rho. This is point P in all coordinate systems. So now r is nothing but 0 to that point, distance from 0 to r. So this is 0. So 0 to r, this is r, and this is theta. This is theta. Now we can relate very easily. Now we can relate all this is z. This is z. So rho already I know. Suppose this is y. Y is equal to rho sin phi, and this is x. X is equal to rho cos phi. Now how I can this is theta, this is r, rho. Rho is equal to r sin theta. Rho is equal to r sin theta. Similarly, this is z, 0 to z. Z is equal to, z is nothing but r cos theta. Z is nothing but r cos theta. So x is equal to rho cos phi already know, y is equal to rho sin phi. So you can relate, you can convert from one coordinate system to another coordinate system very easily with the help of these relations. Suppose x is equal to, I am relating spherical coordinate system with rectangular coordinate system. X is equal to rho cos phi. Rho is nothing but r sin theta. So r sin theta cos phi. So everything is in terms of r theta phi. Similarly, y is equal to rho sin phi. So that is equal to rho is nothing but r sin theta sin phi. Everything is in terms of r theta phi. Z is equal to r cos theta. So this is one set. Suppose if I want to convert back, r is equal to, so r is equal to square root of x square plus y square plus z square, or theta. theta is equal to tan inverse how we can convert theta is equal to z by r. Theta is equal to z by r. Or we can say that suppose rho by z is equal to tan theta. Theta is equal to tan inverse rho by z. Tan inverse rho by z. So tan inverse rho by z, that is equal to tan inverse rho. Already we know rho is nothing but x square plus y square by z. So everything is in terms of x, y, z. So theta in terms of x, y, z. Similarly z r theta phi is equal to tan inverse y by x. We know it. Tan inverse y by x. So with the help of these relations we can convert from one coordinate system to another coordinate system. Any point we can convert from one coordinate system to another coordinate system very easily. So just if you draw like this. So no need to remember, directly with the help of this diagram you can write down what is rho